Hey everyone, I wanted to do a quick, or it's probably not going to be a quick video, but a video about the practice problems that were on your practice test on big ideas. So I wanted to go through them all, and I know I didn't get a chance to go through them all in class, so I thought I'd do a video for it. So a couple people had requested that, so that's what I'm going to do. So the first one gave you a plane with a line, a couple lines in it, and then some other points. So it says name two, basically they want you to name two different ways to call the line PQ, or WQ, sorry. And so the two different ways you can name that line, you could always go the opposite direction and call it QW. That's always a good option when you are naming a line. And then the other one would be to name it by the one letter. And again, you're looking for the lowercase letter, and you would say line G. So the two possible answers here could be line QW or line G. The next one says name another name, or name another way to name segment B to D. The only other way to name a segment is to kind of do the opposite direction, and that's D to B. So again, as long as they're equivalent, so B to D encompasses the same amount of space as D to B. So those two would be equal. And so therefore we can name it either direction. Number 3 says we want to sketch ray AB and line AC. So with this one, if we had a line AC, line, so AC, I then need to have a ray AB. So the same, since they're both using the letter A, you only use the letter A once in your diagram. And so this would maybe one example of how I could write it. So line AC with ray AB. And I know yours is multiple choice, but like this is one possible choice. All right, number 4. This one is kind of the segment addition postulate. So they're asking you to find the length of Q to R, and they want a simplified expression. When they ask you for this, it means your answer is not a number. It means it's an expression. So like think, something in terms of letters like Y's or X's. So in this equation, in order to get QR, we would have to take the entire equation, which is 13y plus 25, and subtract this piece. Now be careful here. You have to use the distributive property. We're subtracting all of 8y plus 5. So you have to put that in parentheses and then distribute. So I'm going to go ahead and do that. I'm going to distribute the negative throughout, and then I'm going to combine like terms. So 13y minus 8y is 5y, 25 minus 5 is 20. And so this would be your final answer for the expression for the line segment Q to R. So again, just make sure that when you are subtracting that you're putting that whole entire thing in parentheses. On the last one, it asks us, so it gives you a segment addition postulate, but it gives you both pieces. So here, you're looking for an expression. So to get from A to C, that's the entire thing. So you're going to add these two pieces together. So if I add both those pieces together and I combine like terms, I get 8x minus 1. And so that would be your expression for that like segment A to C. All right, moving along. On the next one, number 5, says S is between R and S on the line segment R to T. So I'm going to go ahead and draw this because it makes more sense. S is between R and T on a line segment R to T. So RS is 2x plus 10, so that's this piece. ST is x minus 4, and the whole length here is 21. They want you to come up with an equation. So what it did in Big Ideas is it gave you an equation, like a box or whatever to put in your answer, and it says equals 21. So in order for me to do this, what I'm going to have to do, I'm going to grab a separate sheet of paper here to do this on, is in order for me to figure this one out, this is not a simplified expression. I want us to solve for x. So notice the directions didn't say write a simplified expression. So on this one, what I know is if I put 2x plus 10 plus x minus 4, it has to equal 21. So by giving you this whole length is 21. So this is not what you'd put in this box here. You want to simplify this first. So this becomes 3x plus 6 equals 21. So this is the part that's going to go into this box right here. So on Big Ideas, they're asking you for this piece right there. Then they want you to solve for x and then plug it back in and find rs and rt. So let's solve for x. I'm going to subtract 6 from both sides. So I get 15, and I get x to equal 5. So I'd plug 5 in for x. And now all I'm going to do is plug this back in for rs. So rs was 2x plus 10, but since x is 5, then that means it's 10 plus 10. So rs would be 20. And you could either know that since the whole length is 21, then this has to be 1, or when I plug 5 back in here, I get 1. So again, this would be the answer for the equation part because it has to equal 21. Make sure you simplify that. And then x is 5, rs has a distance of 20, and st has a distance of 1. On the next equation, they kind of do the same deal. So we're using the same kind of format here. We're saying r, s, and t. This time they're telling me this is 3x minus 16, and this is 4x minus 8, and they're telling me this whole length is 60. So again, same kind of deal. What I'm going to do here is I'm going to put 3x minus 16 plus 4x minus 8 and have it equal 60. So again, you want to simplify this before you write it into your equation on big ideas. So this would be 7x minus 24. And so that's what's going to go into your equation because that's the simplified version. And then I'm going to go ahead and solve for x. And I get, add 24 to both sides, divide by 7, x to equal 12. And then if I plug 12 back in here, I get 3 times 12 minus 16. So that's 36 minus 16, which is 20, which means this has to be 40 in order for that whole thing to be 60. So those were the answers for those 7 addition ones. Oops, I forgot. We had a few more. All right. So this time they're telling us, so here's my line again, r, s, and t. So this time they're saying rs is 2x minus 8, st is 11, and rt is x plus 10. All right, so they mixed it up a little bit this time, but it's the same pattern. So we're going to say 2x minus 8 plus 11 has to equal x plus 10. So notice in your equation on big ideas, they want you to put something in here that equals x plus 10. So the only thing you're going to do right now is simplify this side of your equation. And so what I'm going to do is I'm going to get 2x plus 8, 9, 10, 11 is 2x plus 3 equals x plus 10. Since the big idea is kind of to say something equals x plus 10, so this is what I'm going to put in over here. So 2x plus 3 is the equation I'm going to put in. Let's solve for x. So I'm going to subtract x from both sides, and then I'm going to subtract 3. So I get x to equal 7. And then rs, if I did times x, or 2 times 7 is 14, minus 8, I get 6. And then r to t, if the piece is 6 and that's 11, that would have to be 17. And the last one on this, so r, s, and t, this is 4x minus 9, this is 19, and this is 8x minus 14. So again, same deal. We are going to go ahead and set up our equation. So 4x minus 9 plus 19, so these two pieces have to add together to equal 8x minus 14. I'm going to go ahead and combine like terms here. So I get 4x plus 10 equals 8x minus 14. And that's what they want you to plug in here because this equation already had it set equal to 8x minus 14. So I'm going to put in 4x plus 10. Now I'm going to solve for x. So I'm going to subtract 4x from both sides. I'm going to add 14. And I'm going, oops, not 8. I'm going to divide by 4. So I get x to equal 6. Now we know x is 6. Let's plug in here. So this would be 24 minus 9, and I get 15. And if this is 15 and that's 19, if you add those two together, you should get 34. Okay. So those were a lot of segment addition postulates, very good questions, kind of giving us kind of a combo stuff of what, maybe not the easiest ones that we've had in our notes and stuff, but definitely ones that will be useful. This next one was about copying a line segment. And so the words on big ideas, and I just want to make sure you went over the correct answers, and then I'm going to show you how to do it with like an actual compass. So it says, use a blank to draw a segment. So what they're asking you to do is to take a straight edge, and they want you to draw a line segment, and it needs to be longer than the original line segment that you're trying to copy. So I'm going to draw a line segment that has to be longer. So the words here are use a straight edge to draw a segment longer than KL. You're going to label one endpoint as M, and then set your blank, which in this case is going to be compass, at the length of KL. So what you're going to do is set your compass here, and you're going to measure it. So you're going to have it line up with one of the little dots on our thing, and mine lines up with W, just because I made a line segment. We're all going to have different lengths because I just made this one up. So mine's going to line up with W. So it says set your compass at the length of KL. Use the compass to mark a point N on the new segment. So I'm going to go down here, put my compass here. So I'm going to put my compass at endpoint M, and I knew that I had it at W, and I'm going to make like a little arc. So now I kind of measured it here, and then I swapped it down here and measured off the length. So I used my compass to mark point N. So here's point N on my new segment. So that's how you copy a line segment. So if this question were to appear on your test, basically what you're looking at is you're looking to kind of fill in the blanks here, because you're obviously not going to physically do the construction, but that's how you physically do the construction. And so I wanted to show you that. All right, so now we're going to get into some definitions. Again, I want to point out the fact these little lines and what they mean, because a couple people got that wrong on the quiz. These little lines mean that they are congruent. So first it asks you, what is a segment bisector? So XY is being bisected. How I know it's being bisected is because this piece and this piece are equal, which means that it's being cut in half. So what is it that's bisecting my segment XY? Well, what is this thing? Well, it's a ray with an end point of M passing through N. So it has to be this. So it's a ray, not a line segment. It's a ray, starts with an end point of M and goes through N. The next thing they want us to do is find XY. So if we know this is a bisector, what do we know about those two pieces? Well, we know that they're equal to each other. So you would say 3x plus 1 equals 8x minus 24. So we set those equal to each other. Now I'm just going to solve for x. So I'm going to subtract 3x from both sides. I'm going to add 24. And I'm going to divide by 5. So I get x to equal 5. Be careful, this is not the answer. The answer asks for the length of x to y. So you have to plug it back in. So if I plug 5 in back here, I get 15 plus 1, which is 16. And then I know this has to be 16 because we already said they were congruent, which means the length of x to y has to be 32. So the segment bisector was MN, the ray MN, and the length of x to y was 32. All right, now we're getting into some questions about midpoint. So I'm telling you endpoints of line segment C to D. So here's C, here's D. This is -2, 0. This is 4, 9. You don't have to draw this out, but I was just showing you. Find the midpoint. So directions, how you find the midpoint is you average your x values. So you take your two x values and you average them, which means that you divide by 2 because there's 2 of them. And then you put a comma, and then you take your y values and average them. So if I do that, remember, your answer should be a point, an x value and a y value. So -2 plus 4 is 2, 2 divided by 2 is 1. 9 divided by 2 is 4.5. And so I don't know if they want a decimal or a fraction here. So they might ask for a fraction, and I know big ideas can be tricky sometimes or picky. Obviously, if you had this work on your paper and you had it right and you wrote it as a decimal as opposed to a fraction and it marked it wrong, I would mark it right. So just be aware that you're going to show all work tomorrow, and that's really ultimately what I'm grading. So that's your midpoint, 1, 4.5. All right, I like question 9. 9 says, I'm giving you the midpoint of G to H. So the midpoint of G to H is at the point -2, 5, and one endpoint is at -3, 7. So you're asked to find the other endpoint. So if you remember, I told you a way to do this is you should look at common distance. So you know that since this is in the midpoint, this piece and this piece have to be equal distance. So from -3 to -2, we went up 1, right? We added 1 to get from -3 to -2, which means if they're the same distance apart, then I have to add 1 to get to this new x value. So -2 plus 1 is -1. Likewise, for your y values, to get from +7 to +5, I subtracted 2. And so again, because we have to have the same distance, I have to subtract 2, so this is going to become 3. So my other endpoint is at the point 1, 3. So question 10 said, how do you find the midpoint given two endpoints? And so the question or the response I'm looking for here is something like you're taking the average of your x's and the average of your y's. Again, if that were on your quiz and you really didn't know which multiple choice question to pick, I would expect that you maybe write me a note on your paper, right? So on the work, and just explain to me there. That way I can be guaranteed that you understand the concept and I can mark it. How do you find the endpoint given the midpoint? So I do it this way. So I'm not even sure that was an option on big ideas, but like, again, what I would be asking you to do here is if this were on the actual test, I would expect that you would choose a choice off of big ideas, but then write down in your notes, in your paper that you're going to turn in, how you actually did it. So that way I can give you credit accordingly in case it marks it wrong. All right, so this one, number 11, find the distance around. So this is all about distance. And so I didn't draw the grid here, but this was at 10 on the x-axis and 80. So this had a distance of 70, and this was from 10 to 50, so this has a distance of 40. And so what I'm going to do here is we're going to find the distance all the way around. So this was at the point, so R was at the point 10, 80, and S was at the point 10, 50. So I need to figure out the length of this hypotenuse here. I need to figure out this length here. So one way to do this is to use the Pythagorean Theorem. And that's probably what I would have done. Or you could use the distance formula. So I'm going to use Pythagorean Theorem because I think it's easier. So to use Pythagorean Theorem, these are your two legs. Those go in for your A and your B. And you solve for C. So 40 squared is 1600. 70 squared, I got 4900, equals C squared. So I got 6500 equals C squared. I'm going to take the square root of that. And I'm on a decimal, I'm going to go 80.62 equals C. So I'm okay with decimals on this. I know big ideas will be okay with the decimals. I don't think they're going to ask you to do anything reduced radical. So find the distance around. So that means I'm going to take that 80.2 and I'm going to add 40 and I'm going to add 70. So for my distance, I got 190.62 units. And that was my answer for that. Again, I'm going to be looking for work. So if you didn't get this exact answer and maybe you rounded differently, but you had all the correct work, then that's fine. The next thing they ask is find Q to M. So M is the midpoint, and again, I marked it because these two pieces are equal. So we have to find the midpoint of line segment PR. So line segment PR, the midpoint would be halfway between our x's, which is 10 plus 10. So I'm going to do 10 plus 10 divided by 2. And then halfway between my y's, which is 50 plus 80 divided by 2. So that's 20 divided by 2, so that's, so this isn't 10. This is, I'm sorry, I had that backwards. Let's try this again. This is 80, 10 as my point. I had it the other way around. All right, let me try that again. So my midpoint here, I'm going to add up my x's, so 80 plus 10 divided by 2. And then my y's would be 10 plus 50 divided by 2. So that's 45 and that is 60 divided by 2 is 30. So that's my coordinates of my midpoint, 45, 30. So next, what it asks you to do is to find the length of QM. So we're going to use the distance formula to figure that out. And so it probably would have been helpful if I had the grid in front of me. I think this is at the point 10, 10. So if I have this wrong, I apologize. I'm not looking at my computer screen because I'm trying to do the video. So, but this is the general idea in case I have that coordinate wrong. And of course, if I do have this one wrong, please shoot me and I will maybe go over it tomorrow at 8:30 if anyone's interested. But anyway, what you're going to do is find the distance between these 2 points. So you can use your distance formula. So I'm going to go ahead and grab another sheet of paper because I'm running out of room. So I want the distance between the point 10, 10 and the point 45, 30. So I'm going to go distance equals 45 minus 10 squared plus 30 minus 10 squared. So y2 minus y1 squared plus x2 minus x1. Actually, I did the other way around. x2 minus x1 squared plus y2 minus y1 squared. All right, so I get 35 squared, which I put in my calculator, and I get 1,225. And then I get 20 squared, which is 400. And then I add those two things together and I take the square root and I get approximately 40.31. So my Q to M is approximately, if I had the right coordinates there, 40.31 units. Fun. All right, now this is kind of just a measure. You're just going to add in a bunch of numbers. They're saying, okay, add from P to M, P to Q, then Q to M, and then M to R. So we got to figure out all these little pieces, right? So if I know this whole length here is 80.62, and I know that these two things are equal, this is about, let me use a different color here so we can have that. This piece right here is about 40.31, we'll say, and this is 40.31. So if I'm going to add, first I'm going to go P to Q. That's 40, plus, and then Q to M, which was 40.313, and then M to R, which is this piece, which is 40.31, plus R to Q, which is 70, plus Q to P. So Q to P is back to 40. Add all those together, and I got a total distance of 230.44 units. Again, very kind of involved question. A lot of just, midpoint using distance formula and just kind of, following along. I probably wouldn't give you something quite this lengthy on a quiz just because it would take a little bit longer, but it's good practice for us because it uses all of the same skills that we've been kind of talking about throughout the course of this unit. All right, let's switch gears a little bit. Now we're talking about polygons. So name. So 1, 2, 3, 4, 5. It's a 5-sided polygon. I want you to know that that's a pentagon. Is it convex or concave? This is convex. Remember, an example of a concave polygon might look something like this. See how one side caves in? That's concave. When everything's kind of popped out, there's nothing that caves in, it's called convex. All right, moving along. Number 13. So number 13 has us finding perimeter. So anything that's horizontal or straight vertical, we can just count squares, or in my case, since I didn't draw the squares, we can just count the distances. So from -2 to 0 is a oops, that does not look like 0, 4. That's all right. So this has a distance of 2. So if I look at the coordinates, and then from here, this is 2, 0 to 2 negative. So we're on the y-axis here. So this has a distance of 2 if I count it. And this is from 0, -2 to 2. So this is a distance of 2. And this has a distance of 2. So I went around and I just did all of the horizontal or vertical distances first because those were the easy ones, right? Now I'm going to do my diagonal distances because that's I'm going to use the distance formula for. So I'm going to figure out the distance between 0, 4 and 2, 0. So I'm going to go 2 minus 0 squared plus 0 minus 4 squared. and I get 4 plus 16, which is the square root of 20. And it's probably going to ask you for a decimal, so let's just put that into our calculators, and I get approximately 4.47. All right, so to get now we need to go this length. So I'm going to do the distance formula. So I'm going to go 0 minus negative 2 squared plus negative 2 minus 2 squared. So 0 minus negative 2 would be 2. So 2 squared is 4. This would be 4, and so it's the same thing. So root 20, which is 4.47. So obviously I'd like to see your work if you were on this on a quiz for sure. And again, these ones you can just count squares, but the other ones I would expect to see some sort of work, whether it's the distance formula or Pythagorean theorem. Okay, all right, so we're going to go ahead and add those together. So I'm going to add the two 4.47s and then 2, 4, 6, 8 plus 8. So I got a total perimeter of 16.94 units. Again, if we rounded differently, you might have a different answer than me, slightly, but it shouldn't be completely off, provided that I copied it down correctly. So we should be pretty close. Okay, moving along. Find the area of this one. All right, so what I thought I'd do here is just sketch. So 0, 0 is W, 0, 3 is X, negative 3 is Y, and negative 3, 0 is Z. Part of this is, can you graph this correctly, right? This looks like a square to me, but it's always good to double check. So I'm asked to find the area. So as long as this is all, so these are all vertical and horizontal distances, and if you measure, these are all 3 units in length. So it is indeed a square. So then how do you find the area of a square? You take one side and you square it, or you do base times height. Either way, you get 9 units squared. Moving on. Number 15 has us doing perimeter. So again, if there's any, it doesn't really look like there's any horizontal or vertical distances. So we're going to have to figure all of these things out, which is kind of annoying, but that's okay. So I'm going to do this on a separate sheet of paper because I'm going to run out of room. I can tell. So I'm going to start with negative 5, 4 and 0, 3. So I do 0 minus negative 5 squared plus 3 minus 4 squared. So I get 25 plus 1. So I get root 26. So square root of 26 is about 5.10. Okay. Next one, I'm going to do the point 0, 3 and the point 4, negative 1. So I'm going to go 4 minus 0 squared plus negative 1 minus 3 squared. So I get 16 plus, so that's 16, so that's the square root of 32. And if I put that in my calculator, I get about 5.66. So this one has the same distance because it's a rectangle, so I can save myself a little bit of time there. Okay, let's do this one. I wonder if it's the same as the other one, but we'll check. So now I'm going to do the point 4, negative 1 and the point 4, negative 5. Actually, this one, it's vertical, right? 4, negative 1 to negative 5, that's a distance of 4. I don't really need to do any distance formula for that one. Didn't really look like it on my grid because I didn't actually copy it on graph paper. So on yours, I'm sure you'll be able to tell. All right, so this distance right here, so that one I might need. So I'm going to do 2, negative 3, and then 4, negative 5. So let's do the distance formula. So 4 minus 2 squared plus negative 5 minus negative 3 squared. So I get 4 because that's 2 squared. And then this gives me negative 2 squared. So it's root 8. And I get about 2.83. Okay, almost done. If you haven't memorized the distance one but yet, I'm pretty sure after this one you will. So -2, 1 is the next point, and -5, 4. So again, I'm going to do -5 minus -2 squared. Watch all your negatives. 4 minus 1 squared. So this gives me -3, 2, 3, 4, 5. So that's 9. And this gives me 3 squared, which is 9. 9 plus 9 is 18. Square root of 18 is 4.24 approximately. Okay, kind of a ridiculous problem. I still like it though. I know it's tedious, but it does kind of reiterate the distance formula a whole bunch. So that's why I like it. So you can hate me for making you do it a million times, but hopefully you'll realize that it was, all because I want you to make sure you understand this. All right, what did I get? I got a total, if I added those correctly, 27.49 units. Okay, that was a fun one. All right, we're nearing the end. This is a long video, so bear with me. So the measure of angle AOC is 30 degrees. Oh, so what they're asking you to do here was there was a protractor, and they're asking you to read that angle. So it was like the protractor kind of had it like the angle like this. So what you needed to do is read it this direction. And again, you have to pay attention to the fact, is the angle acute or is it obtuse? So obviously from here to here is a small angle, less than 90 degrees, so it's acute. So you'd use the smaller numbers. So the correct answers on big ideas would be 30 degrees, and you'd classify that as acute. All right, now we get into some angles. It says find the measure of LMP, angle LMP, and then angle NMP. So what I have up here are two angle measures. So what do we know about these two angles? So this is kind of identifying the types of angles that we've been talking about. So if I put this angle and this angle together, we call that a straight angle. In other words, it forms a linear pair. In other words, it's supplementary. In other words, it adds to 180 degrees. So I'm going to put, and I did something wrong here. I copied this wrong. I think this is supposed to say 16x. I hope so, at least, because I copied it wrong and I can't look it up right now. Okay, so I think this says negative 16x plus 13 and then negative 20x plus 23. We're going to add those two things together and set it equal to 180. So let's combine some like terms. I get negative 36x, and 13 and 23 gives me 36. And then I'm going to solve. So 180, and I'm going to subtract 36. Excuse me. And then I'm going to divide by negative 36. I think I was right. All right, I get x equal negative 4. Remember, you are not done. You are not finding x, you are finding the angle measures. So LMP, negative 16x plus 13. If I plug in negative 4, negative 16 times negative 4 gives me 64. 64 and 13 gives me 7 degrees. And then the other one, you could always just do 180 and minus that, and I got 103 degrees. All right, let's do the next one. I have noticed that these two angles are complementary, and you might ask how I knew that, and that's because of this little right angle symbol. So those two angles are complementary, which means they add to 90 degrees. So I would do minus 43 plus 8x plus 18 equals 90. So again, I'm going to combine like terms, so I get 23x. Negative 43 plus 18 gives me negative 25. Just give me water noise. And then I'm going to take 90 and I'm going to add 25. And then I'm going to divide by 23. All right, again, I found x. That is not my goal here. My goal is to find the angle measures. So if I plug it into RSQ, oops, I didn't even label this. Well, I don't know which one's which, but I'm going to plug it back in here. So if I plug it into here, 15 times 5, thank you, and then subtract 43, I get 32 degrees. And then for the other one, I would subtract from 90, would have to be 58 degrees. So I might have these mixed around because I didn't write down the actual letters on my paper, so I apologize. But the two answers are 32 and 58. And so you would have to look at yours to double check. This was quite the feat for me to try to go through this video because I couldn't do a video and look at big ideas at the same time. So, and I don't have a printer at home. I wrote all this all out. All right, QS bisects the angle PQR. So again, if it bisects it, we know that those two pieces are congruent or equal. The measure of PQR, which is this entire angle here, is 119 degrees. Find the measure of PQS and RQS. Well, if these two angles are equal and the whole thing is 119, you just divide by 2 and you get 59.5. So each of these angles would be 59.5 degrees. Number 20. 7 is a supplement of 8. Angle 7 is a supplement of angle 8. If angle 7 is 109, what's measure of angle 8? Well, supplement means that they're adding to 180. So 180 subtracting the 109 that you had for angle 7 means that angle 8 has to be 71 degrees. Number 21, are angle 6 and angle 8 vertical angles? So if you look at it, angle 6 and angle 8, I'm going to grab my highlighter here. Angle 6 and angle 8 are indeed vertical angles. And how I know is because they're across from each other. Now, that's probably not what Big Ideas is going to say as one of their options. It's going to say something like they have two pairs of opposite rays or something like that, I think they say, which is true as well. I always just kind of look at them, and when they're across from each other like that, they're vertical. But I think the formal definition says something like that they both make up two pairs of opposite rays. So that would be your correct answer. 22, the measure of an angle is 1/4 the measure of its complement. Find the measure of each angle. All right, so the measure of an angle, so let's say this angle is x. So the measure of this angle is equal to 1/4 the measure of its complement. So you might be wondering where I came up with this. So let me walk you through this. So the measure of an angle, so that's x, because we don't know what it is 1/4, that's the 1/4, times the measure of its complement. So this angle's complement, any complement would be 90 minus whatever you started with, right? So that's what I got here, 90 minus x. So find the measure of each angle. All right. I have x equals, and I'm going to distribute. So I get 22.5 minus 1/4 x. So this is 1x, and I'm going to add, so I get 1.25x equals 22.5. And then I get 18. I figured out that x is 18, which means, since that's the measure of one angle, that means the other angle is 90 minus 18, which is 72. So the smaller angle has to be 18 degrees, and the larger angle has to be 72 degrees. Again, definitely a little bit more complicated than just kind of knowing complements, but I thought this was a good question to kind of, challenge us a little bit, but it also pulls in some stuff from algebra, which I enjoyed. All right, we are in the home stretch. 2 more questions. Next one, linear pair, one angle is 115 degrees. All right, so if you have a linear pair, that implies, so you're drawing an example of a linear pair. So here's an example of a linear pair where one angle is 115 degrees. There you go. So in order for this to work, then we have to make the obtuse angle 115. You might have also noticed that this angle was 65. And how I got that is because I subtracted it from 180. So I think they asked you to pick the diagram. So a linear pair has to look like the two angles that form a straight line. All right, last question. 2 angles form a linear pair. The measure, so I'm going to draw that. 2 angles form a linear pair. The measure of one angle is 15 degrees less than 2/3 the measure of the other angle. Okay, so again, a little more algebra in here, kind of a flashback to algebra 1. So the measure of one angle, so we'll call that x, equals 15 less than, which means you're going to subtract 15, 2/3 the measure of the other angle. Well, if one angle is x, how do we figure out the other angle? Well, the key is that they're a linear pair. So if one angle is x, then the other angle has to be 180 minus x. Because both of them together add up to 180. And so if you already know that one angle is x, the other one has to be whatever 180 minus x is. So the measure of one angle is 15 less, minus 15, 2/3 the measure of the other angle. So this represents the measure of one angle, and then this represents the measure of the other angle. So let's see if we can figure this out. I'm going to go ahead and distribute. So I get x equals 180 times 2/3. I get 120 minus 2/3 x minus 15. So I'm going to go and put the 120 and minus 15 together. And then I'm going to add 1 and 2/3. So I'm going to add 2/3 to both sides. So I'm just going to change that into a mixed number. I'm sorry, an improper fraction, I should say. And now I'm going to go ahead and solve for x. So I'm going to multiply both sides by the reciprocal. And I got 63. So if one angle is 63, then the other angle is 180 minus 63, which is 117. All right, that question, again, challenging. I wanted you to kind of, I know this review, and not to say that these are the exact same questions on your test, that's not how I generally do things, but I'm always looking to challenge you. And so I am looking for you to kind of push the envelope a little bit when it comes to some of the geometry concepts. So it's not just that I want to make sure you know linear pair, or I'm going to incorporate as much algebra as I can, and try to pull back some of that stuff that you learned last year, and kind of hopefully help you to remember that, so that next year into Honors Algebra 2, it's not so much big of a stretch. All right, so that was a long video. I apologize, but hopefully it was helpful. If you have any questions, remember, we'll be on Zoom tomorrow starting at 8:30 to answer anyone's questions if you so choose. Okay, bye guys.